Good morning, fifth graders. We're going to look at this week's warm-up, Q1.7. We're going to start by finding the quotient, 52,176 divided by 8. What should I do first, guys? List those multiples. So I've listed the multiples 8 through 64. I think that should be enough. Because when I look at my problem, I know that 8 cannot go into 5. I know that 8 can go into 52. Some of us, I've noticed, have been placing that X. If it's not able to go over that place value, that helps me space out my place value. So when we look at it, we know that 8 will go into 52. How many times? 6 times. 6 times 8? 48. Now I'm going to subtract here. I'm going to have to do some regrouping. So one of these are going to get smaller. The other will get bigger. 12 minus 8? 4. 4 minus 4 is 0. This is where I'm going to check my work here, guys. I see that this 4 is smaller than this 8. So that means I can continue here. I'm going to go ahead and bring down the next place value, that 1. So now I have 41. I need to now find out how many times will 8 go into 41. Tell me. 5 times. I know that 5 times 8 is 40. 41 minus 40 is equal to 1. Okay, so I'm going to check. When I check, I see that this 1 is smaller than this 8. So now it is time to bring down the 7. How many times will 8 go into 17? 2 times. I'm going to put it right here above that 7. 8 times 2 is 17 minus 16. 1. When I check, this 1 is smaller than this 8. So now I can bring down this 6, which gives me 16. 8 will go into 16. 2 times 8 equals 16. 16 minus 16 is 0. My final answer is? Great job. All right, in our next problem, they want us to draw a model to represent the following problem. Well, here I have 2 times 7. They want me to draw a model. When I multiply, I know that I have repeated addition. I have equal groups here. There are 2 ways I could have done this. I could have made 2 groups. And what would I put in each group? 7 in each group. This is one model to represent 2 times 7. When I count each of those dots, I know that it'll be equal to 14. So that is a model representing 2 times 7. There may have been some 5th graders who modeled 2 times 7 as 7 groups. Okay, we could have had 7 groups. Once I have my 7 groups, how many would be in each group? If I put 2 in each of the groups, it is equal to 14. So here are 2 models of 2 times 7. All right, so let's look at our PEMDAS problem. I'm going to go ahead and write it out. I'm sure that my 5th graders have already written it out on their scratch sheet of paper. They also have written out the acronym for PEMDAS and those steps that we're going to follow. So we are going to start with PEMDAS. Let's start with our parentheses, which is 34 plus 6, which is equal to 40. Once I have my 40 listed, I'm going to bring everything down. I have no more parentheses, no exponents, no multiplication. But look here, we have some division. 40 divided by 2 is equal to 20, which is my final answer. All right, so we're going to look at the next one, which is solve the following problem. We have 6 and 304 thousandths times 10 to the fourth power. I'm multiplying a decimal here. So I know since we're multiplying, I could move my decimal to the right. How many times? 4 times. So I'm going to rewrite the problem. When I rewrite my problem, I'm going to pick up this decimal. I'm going to move it one place value, 2, 3, and 4. There's my final decimal. I'm going to rewrite this with my new decimal. I'm not going to use this old decimal. I'm going to bring everything down and place my decimal here, which gives me a final answer of 63,040. So if we move on to our next one, we are ordering the numbers from greatest to least. And I do like to put a little note just to reminder that I'm going from greatest to least, or greatest to least. Okay. So I'm looking for my biggest number here. Some of us have already looked at our whole numbers. And we were able to find the greatest digit here, which was what? 34. We know that 34 is the greatest. Then we go back to our numbers. We're looking for the biggest one. All my whole numbers are equal, but when I look in the tenths place, I see a 1 here, which is greater than the other tenths. So that would be my next greatest value. Show us another way to do this. So I'm going to move on to the next greatest value, which is going to be what, guys?
33 and 100.
Very good. 33 and 100. And my least value here is 33. So 34 is greater than 33 and 10 hundredths, which is greater than 33 and 1 hundredths, which is greater than 33. Okay. Any questions here? I noticed some of you came and wrote down a 1 under 34, showing that it was the greatest, a 2 under 33 and 10 hundredths. You wrote a 3 under 33 and 100, and a 4 under 33. All right, so the next one says, show 8/10 3 ways. A lot of us saw this picture and we knew that this whole was broken into tenths. So we can shade in 8 of our tenths. I'm sure you've already done that. We could also write 8/10. We also can write it as a decimal suggested by Allie. And that would look like 8/10. We could also do what, Ace?
Expanded form.
Expanded form, where we show the digit times the place value. And that could be done 2 ways as well. We could also show 8/10 by what, Hallie? In fraction form, where I have 8 over 10. Another way, Kayon?
Word form.
Word form, thank you, sir. Which was already in the question, but I can show it by writing 8/10. Or I could say 8/10. So these are several ways that we can show 8/10. It looks like we have 7 ways. Yes, Allie? We have 7 ways to show 8/10. Great job, guys. All right, guys, so now we are at solve the following. Multiplying multi-digit numbers. This is the skill that we're going to be practicing this week. Most of you are already whizzes at multiplying multi-digit numbers. So if I could get your help this morning, when I am multiplying 367 times 86, I'm going to multiply this 6 by each digit so that I can get my first partial product. 7 times 6, 6 times 6, plus 4 more, 6 times 3, plus 4 more, 22. Okay, we're going to move right along to our second partial product. So now we have our second partial product. We're now going to add those products together for a final answer. All right, so when I'm adding 2 plus 0 is 2, 0 plus 6, 2 plus 3, 9 plus 2, carry my 1, 1 plus 2, my final answer. Very good. Don't forget to line up those place values. And again, look at those two partial products. All right, so the last one, we are looking for the value of the underlined digit. And we can see that which digit is underlined? The 7 is underlined. So you know I like to prove my answers. So I'm going to start here. I know that this 5 is in the thousands place. I know the 6 is in the, I know the 7 is in the 8. There's my decimal. My decimal separates my whole numbers and my parts. This 3 is in the 2. Oh, yes. And the 1. Very good. So I went ahead and showed what I know. If I'm looking for the underlined digit, I can see that the place value is in the tens, but the question is asking me the value of the underlined digit. What's the value of the underlined digit, guys? 70. Very good. 70 is the value of that 7. Great job, guys. Remember to rewind, pause, to practice for your test on Friday. Have a great week.